Hi everybody, in this video we're looking at the function f of ab that's defined to be 2 to the a times 5 to the b. Our domain is the whole numbers and our codomain is also the whole numbers. So in this function, the first coordinate becomes the exponent of 2 and the second coordinate becomes the exponent of 5. For example, if I have f of 2, 1, that means I have 2 squared times 5, which is 20. That would also mean f of 4, 2 is 2 to the 4th times 5 squared, which would be 16 times 25, which equals 400. We would write that as f of 4, 2 equals 400. Because we're going from whole numbers to whole numbers, it is okay for one of our numbers to be 0, like f of 0, 3 would be 2 to the 0 times 5 cubed. Here, 2 to the 0 is 1, 5 cubed is 125, which says f of 0, 3 is 125. If we flip that around and try to find the input that goes to a specified output, we need to think through our strategy. Let's say we want to find f of ab that's equal to 500. This means we want to express 500 as powers of 2 and 5. The easiest way to do that is to start by prime factoring 500. So if we have 500, we might first think of that as 5 times 100. Then 100 could be 4 times 25. We know 4 is 2 squared, 25 is 5 squared, so now everything is expressed as either a 2 or a 5. I'm going to take these three outputs and put them together. 500 is 2 squared times 5 cubed. That means we want to grab those exponents and use them in our function. We would have f of 2, 3 is 2 squared times 5 cubed, which is 500. Let's try that again. This time we're going to have f of ab is 32. So we'll start just like last time. We'll try to prime factor 32. And notice that 5 is not a factor of 32, so we're going to concentrate on our 2. 32 is 2 to the 5th, so we know a is going to be 5. We still have to have a power of 5 to be our b, but we can do that by using 5 to the 0. We take this 2 to the 5th and the 5 to the 0, and we write our number 32. We grab the exponents to be our a and b, so we have f of 5, 0 is 2 to the 5th times 5 to the 0, which is 32. Now this isn't going to work for all numbers. We cannot express every number as a product of powers of 2 and 5. So let's look at how we will know when it doesn't work. What if we have something like f of ab and we want it to be 600? Well, we would prime factor it. I have 2 cubed times 3 to the 1 times 5 squared. And the problem is that 3 can't be a factor. Since we can't express 600 as the product of powers of 2 and 5, we know that this number is not in our range. So as a wrap-up, when a function is defined using exponents, prime factorization can help us work backwards from an output to the corresponding input. We'll start out by finding the prime factorization of the number, then we'll do a quick check to see if those factors are allowed to be in our product. If the factors work, then we will just match the exponents to the coordinates of the function.